So welcome back, and right now we're going to be talking about chemical composition. Let's remember that a mole, which is denoted by letter N, is the amount of substance, and 1 mole of any particle, such as an atom or molecule, has 6.022 times 10 to the 23 particles, such that if we say that we have a mole of atoms of oxygen, we have 6.022 times 10 to the 23 atoms of that oxygen, and this is Avogadro's number. This is related to mass through the atomic mass or molecular mass or molar mass. I'm going to be stating these as synonyms. And this mass is the mass per unit mole. So we have that the mass is going to be equal to the molar mass times the number of moles. And this molar mass or molecular weight, we can find it in the selected physical properties data. So, or we can calculate it as well. Let's say for CH3COOH, which is acetic acid, we're going to multiply the number of atoms times the atomic mass of each of the atoms. So 2 times the atomic mass of carbon, plus 2 times the atomic mass of oxygen, plus 4 times the atomic mass of hydrogen, because we have those amount of atoms, 2 carbons, 4 hydrogens, 2 oxygens, right? So this is 2 times 12, 2 times plus 2 times 16, plus 4 times 1, more or less, yielding to the 60 atomic mass units, which stands for gram per mole, or kilogram per kilomole, or pound mass per pound mole, okay? And if we have mixtures of many components, we can have the mass and mole fractions. So the mass fraction is going to be the mass that is the amount of mass that we have of one component over the total mass, and that's going to be the mass fraction, denoted by X, which is the kilograms of that component over the total kilograms, or grams of that component over total grams, or pound mass of that component over total pound mass, right? And the same is with mole fractions. The mole fraction is the amount of moles that we have of the component in the mixture over the total mass of the mixture, right? And you can convert from mass fraction to mole fraction with the use of the molecular weight, or vice versa, from the mole fraction to the mass fraction as well, with the use of this molecular weight. Let's have an example. Earth's composition is usually given as the mole fraction 78.08% of nitrogen. So we can go from mole fraction to percent mole just by multiplying this mole fraction times 100, and then that's a percent. So we have 0.7808 of nitrogen, 0.2095 of oxygen, this amount of argon, this amount of carbon dioxide. We have a lot of more components, but let's just stick with those 4. These are the main ones. If we add this up, this will yield to 1. So the sum of all the mole fractions yield to 1, as well as the sum of all the percentages yield to 100. If we have the molar mass and we want to get the mass fraction, we can do it for 1 mole of the mixture. Just multiply 0.7808 times 28, 0.2095 times 32, and so on and so forth. So this will add up to 28.9541. This will mean something in a minute. And then in order to get the mass fraction, you just divide this 21.86 over the total amount of mixture, right? So this over this, 6.7 over 28.95, etc. This has to yield to a sum of 1, more or less. And then if you want the percentage mass, you just multiply this times 100, right? Yielding to a sum of 100% at the end. Commonly speaking, we take the percentage mole of 79% of nitrogen and 21% of oxygen for our calculations. So we're going to get rid of argon, carbon dioxide, and those things, right? And the average molecular weight of this mixture is just this mole fraction times the molecular weight of that component, and we add all this up. We have already done that. once again, for air, if we take nitrogen as 0.79 and oxygen as 0.21, we just multiply this times this, or molar mass. This times this molar mass, we add up and we get the 28.84 atomic mass units or grams per mole, or so on and so forth. This is exactly the same that we have calculated here. And we can actually say that the molar mass or average molecular weight of this air mixture, we can say it's 29, okay? So that's it for right now, and see you later, okay?